The fourth dimension is one of the most fascinating ideas in science and mathematics. Many people think it refers to a hidden place or a mysterious world beyond human understanding. Movies and science fiction often portray the fourth dimension as a magical realm where people can teleport, travel through time, or disappear into another universe. While these ideas are entertaining, the real meaning of the fourth dimension is much more interesting because it combines mathematics, physics, and our understanding of reality. To understand the fourth dimension, we should first look at the dimensions we already know. A first dimension, 1D, is simply a straight line. It has only one direction, forward and backward. If you imagine an ant walking along a wire, it can only move in those two directions. The second dimension, 2D, adds another direction. Instead of only moving forward and backward, you can also move left and right. A sheet of paper is a good example of a two-dimensional surface because it has length and width, but no measurable thickness. The third dimension, 3D, is the world we experience every day. It includes length, width, and height. Everything around us, people, buildings, trees, animals, and planets, exists in 3 dimensions. We can move left and right, forward and backward, and up and down. So, what is the fourth dimension? In modern physics, especially in Albert Einstein's theory of relativity, the fourth dimension is time. Instead of thinking of time as something separate, Einstein explained that space and time are connected into one concept called space-time. Every object has a position in 3-dimensional space and also exists at a specific moment in time. Without time, you cannot describe where or when something exists. Imagine you are sitting in your room. Your location can be described by its length, width, and height. However, that description is incomplete unless you also include the time. Someone sitting in the same chair yesterday is not the same event as someone sitting there today. Time becomes the fourth coordinate that tells us exactly when something happens. Another way to understand this is by thinking about a movie. A single photograph captures one moment in time. If you take thousands of pictures and play them quickly one after another, you create a moving video. Each frame represents a different moment. Similarly, our lives can be imagined as countless moments connected together through time. We experience those moments one after another, always moving forward. Mathematicians also study the fourth dimension in a different way. In mathematics, a fourth spatial dimension is an extension beyond the 3 spatial dimensions we know. Just as a cube is the 3-dimensional version of a square, a 4-dimensional shape called a tesseract is the 4-dimensional version of a cube. Although humans cannot directly see a tesseract because we live in 3-dimensional space, mathematicians can describe it using equations and create 3-dimensional projections of it, much like a shadow represents a 3-dimensional object on a 2-dimensional surface. A helpful analogy involves imaginary beings living in a 2-dimensional world. These creatures would only know length and width. If a 3-dimensional sphere passed through their world, they would only see a circle that appears, grows larger, becomes smaller, and then disappears. They would never see the whole sphere because they cannot perceive the 3rd dimension. In the same way, if a 4-dimensional object entered our 3-dimensional world, we might only see part of it and find its behavior impossible to explain. The 4th dimension has many important uses in science. Physicists use the concept of space-time to explain gravity, the movement of planets, black holes, and even the expansion of the universe. According to Einstein, Gravity is not simply a force pulling objects together. Instead, massive objects like the Earth and the Sun bend the fabric of space-time, causing other objects to move along those curves. This is why planets orbit the Sun and why objects fall toward Earth. The idea of the fourth dimension has also inspired many books, films, and scientific discussions. Some stories imagine that beings living in the fourth dimension could see every moment of our lives at once, or move through time as easily as we walk through space. While these ideas are exciting, there is currently no scientific evidence that humans can freely travel through time or access a higher spatial dimension. In conclusion, the fourth dimension is a powerful concept that helps us understand the universe. In mathematics, it represents an additional spatial direction beyond the three dimensions we experience. In modern physics, it is most commonly understood as time, combined with space to form space-time. Although we cannot directly perceive the fourth dimension in the same way we see length, width, and height, its effects are observed throughout the universe. From the motion of planets to the behavior of light and gravity, the fourth dimension plays a crucial role in explaining how reality works. It reminds us that the universe is far more complex and fascinating than what our eyes alone can see.